We're going to look at the answer to the worksheet speed of light and energy. For the parts of the wave, we have the origin. Top of the waves are going to be the crest. Bottom of the waves are going to be the trough. And from crest to crest is going to be the wavelength. The symbol for wavelength is lambda, which has higher energy. If we look at the electromagnetic spectrum, but just look at light, R-O-Y-G-B-I-V, we know as we go across the spectrum from red to violet, energy is going to increase, wavelength is going to decrease, frequency is going to increase. So with that said, we can look at this. Which has higher energy? Well, it's going to be violet light, which is a longer wavelength. Since it's red's down here, red's going to have the higher wavelength, the shorter wavelength, longer wavelength, which is a higher frequency. Since frequency increases this way, violet is going to have the highest frequency. Now looking at the equations for light. C equals lambda V. C is the speed of light, 3 times 10 to the 8th meters per second. This is our wavelength, and this is going to stand for frequency. Frequency is, the units is hertz, or things per second, or seconds to the -1. And wavelength is going to be in meters. To help us with this, we have our easy to solve triangle. This is C, lambda V, I'm going to call it. And we have 3 times 10 to the 8th is going to be our constant. So when we work our problems, the frequency of the wave, here's our frequency with our unit to the -1, find its wavelength. To find wavelength, I cover it up, it's going to be C divided by frequency. So C is going to be 3 times 10 to the 8th. Our frequency is going to be 6 times 10 to the 11th. And this is going to equal our wavelength. To put this in your calculator, you'll say, well, let's give you the answer first. If you do it, it's going to be 0.0005. Or you can make that, of course, 5 times 10 to the -4th, and this is all going to be in meters. If you're not sure how to put this in your calculator, you do not hit times 10. You'll do this. You hit your 3 button, hit your EE button, and then you hit your 8 button. And then you hit divided by, then you hit your 6 button, your EE button, your negative button, and then you'll type in 11. And that was how you put that in. If the wavelength is 4 times 10 to the 7th, find its frequency. So if I want to find frequency, I'm going to cover up frequency. It's going to be C divided by wavelength. So frequency is going to be C, which is 3 times 10 to the 8th, divided by wavelength. This is 4 times 10 to the -7th meters. We should put that in a calculator. 3EE8 divided by 4EE -7, and that's going to give you a 7.5 times 10 to the 14th hertz. Okay? And then solving these now in our chart, you're just either going to solve for V or lambda. Let's do this one, solving for lambda. So if I solve for lambda, I'm going to cover up. It's going to be C divided by V. So lambda is going to be C, 3 times 10 to the 8th, divided by frequency, which the problem says is 7.78 times 10 to the 22. And if you solve that, that's going to be 3.9 times 10 to the -15. This one is going to be 6.7 times 10 to the 20th. This one's going to be 6.7 times 10 to the 8th. And this one's going to be 5.5 times 10 to the -11th. To find what type of wave it is, you can either look at the wavelength or the frequency. So let's go ahead and look at the frequency as 10 to the 22nd. And we'll look at our chart on the back. Our chart on the back shows frequency and wavelength. Notice our frequency, if we're looking at 10 to the 22nds, that's going to be in the cosmic ray. -15 is going to be even past that, so cosmic is going to be our answer. So the answer for this is cosmic. If you do the other ones, this one ends up being gamma, this one ends up being radar, and this one ends up being X-ray. Next part is our equation for energy. E equals hv. E is going to stand for energy in joules. H is going to be a constant, 6.6 times 10 to the negative 34th. And frequency is going to be, V is going to be our frequency, and it's going to be in hertz again. So our easy math for this is E, H, frequency, and H is 6.6 times 10 to the negative 34. Working a problem, find the energy, a cover-up energy is going to be H times V. So energy equals H. We say that H is 6.6 times 10 to the negative 34th. And we say that frequency is 6 times 10 to the 14th. And that gives me an energy of 3.96 times 10 to the negative 19th. And that would be a joule. If we're trying to find its frequency, cover-up frequency is going to be E divided by H. And so E was given as 4.97 times 10 to the negative 22. H we know is our constant, 6.6 times 10 to the negative 34. And if we do this, we'll end up with 7.5 times 10 to the negative 11. And that will be a hertz. Okay. Putting the answers in for the rest of the chart, you'll do it just like using the equation that we were doing. That's 5.1 negative 20, 3 times 10 to the 17th, 3.8 times 10 to the 11th. And I forgot to do this one ahead of time. Then you'll check your back of the sheet for those waves just like we did last time. For the back of the paper, just going to quickly just look at the key, and what we'll do here is again we will find the frequency of a wave from the following. So if the frequency is, find the following, so we're going to find wavelength. Well, the only equation that has wavelength and frequency is this one, so we use this equation. If we're trying to find energy, we'll have to use this equation. So it's just getting you to try to figure out which equation to use. And again, wavelength has to be this one, energy has to be this one. The next one's a little trickier. If the wavelength of the wave is, find the following, frequency and energy. Well, if you're trying to find energy, there is no wavelength given, so you cannot use this equation. So how do we find energy? Well, we have to know frequency. So we'll have to use our equation first with wavelength, using our wavelength equation. So we'll find our frequency, c divided by lambda. So now we know our frequency because we're given the wavelength, and then we'll take this answer, plug it in for our frequency here. So in order to find frequency or energy when the wavelength is given, we have to work two problems. And I filled in the chart here for you to answer the rest of the problems.